Hi, today we are going to kind of do a little bit of review on composite functions and then do some more work, add a little bit of something that you haven't done last year on decomposing functions. So let's start with composite functions. A composite function is where you can take two or more functions and put them together. So it's possible for me to write f of g of x or I could write that as f, kind of like it looks like fog, F-O-G of x. Those both mean the same thing whenever you're doing that. So that means that I'm taking two functions and I'm taking the values of, it would be like saying I have g of x, or I have x. I'm going to put it into the g function and I'm going to get an output. So input to output, and then I'm going to take that answer and I'm going to insert it into the f function. And then I'm going to get my final output answer. So your original output from your inside function becomes the input of your outside function. Okay, so I know you guys have done this before, so I don't want to take a lot of time talking about that piece of it. I want to just kind of go through and remind you of how you would work some of the equations that you would have if you were just doing a composite function. So let's say that I have the two functions that are listed here. F of x is equal to x squared minus 7, and g of x is equal to 3x plus 4. If I wanted to find f of g of 3, start with your inside function. So you would take g of something equals 3 times something plus 4. Okay, so I'm going to take and replace the x value into that function. And it says I need to place a 3 here and I need to place a 3 here. And now I'm going to evaluate that. So in evaluating that problem, I'm going to take 3 times 3, which is 9 plus 4, and that will give me 13. So g of 3 is 13, or in other words, the point 313 will appear on my graph. Okay, that does the outside part of the function. Now I'm going to need to take f of something equals something squared minus 7, and it says take this and input it into my f function. So that's going to input a 13 and a 13. So 13 squared would be 169 minus 7 is going to be 162. So my composite function f of g of 3 would equal 162. And I found the value of my composite function. Okay, and I'm not going to change my functions around on this. I'm just, whoops, sorry about that. I'm just going to kind of keep using this function to do a few things with that so that we can kind of see what happens when we put them all together. All right, so it's possible for me to have, if I could go the other direction. So I could say, let's do g of f, I'm sorry about that. Let's write it just in a little bit different format on it this time. So if I said that we had G, if I had that particular notation, so again, this is going to mean the same thing as G of F of X. Okay, so that's what that means. So if I switch, so if I wanted G of F of X, this time I don't have a number there, I just have a variable. So I'm going to say F of X equals X squared minus 7. So now if I want the G function, G of something equals 3 times something plus 4. So this time it says, take this function and input it here and here. So G of X squared minus 7 equals 3 times X squared minus 7 plus 4. So 3X squared minus 21 plus 4, or 3X squared minus 17. So G of F of X equals 3X squared minus 17. Simplify the problems as much as you can whenever you're doing one of these problems. So if I were to switch this around, just to kind of make sure that you understand what I mean when I tell you to simplify it, you would have, so let's say I reverse these two problems and I have F of G of X. So that would be F of something equals something squared minus 7. So this time it says I'm going to take my G function, which is 3x plus 4, and I'm going to insert that into my F function. So F of 3x plus 4 equals 3x plus 4 squared minus 7. Now you need to do the math. So square the problem out. So 3x plus 4 squared would be 9x squared plus 24x plus 16 minus 7. And then combine your like terms. And then that would be the value of the function f of g of x. So if there's a number inside, you use the number to go through the problems. If there is a variable on the inside, your answer then is going to contain a variable. Right, that is if I'm giving you what your input value is, but I don't always have to give you an input value. It is possible that you're going to be given the output and I'm going to have to find my input. So if I had something like, sorry, it's a little bit easier if I do the problem. All right, so if I were to have a problem like G of F of X is equal to 10. Okay, this time I don't know the inside. When I know the inside, I work from the inside to the outside. Since I don't know that part right now, I know I have to think about it like this. G of X is equal to 10. G of X, so the 10 needs to be replaced with G of X. So 10 equals 3x plus 4. And I'm going to solve this for x. So I can subtract 4. So 6 equals 3x, and you get x is equal to 2. Right, so that gave me the outside answer that I need. So now I need to think, okay, now that means that taking the second piece of that would give me, well, I now know that f of x has to equal 2. So take my f of x function and get x squared minus 7 equals 2, x squared equals 9, x equals plus or minus 3. So when I look at my input, I'm going to get plus or minus 3. So now let's think about that in terms of what it could look like with a table or if I was using a graph. So that what the problem was, g of f of x is equal to 2. So if I'm using a table, I'm going to say, all right, where is x equal to 2? Where is the y value in my table equal to 2? So that would be, this is equal, well, that was good. So I erased that. Awesome. So this is where the g function is equal to, oh, I'm sorry. It was supposed to equal 10. I remember the answer instead of the problem. All right, hang on. So this is equal to 10. So when the y value is 10, the x value is 2. Now I come over here and go, where is the y value 2? Here and here. So this time I can get 2 answers for the problem, and I get positive 3 and negative 3. Now, if I look here at the graph where it says g of x equals 10, so I look at 10 on my graph, which is here, and that is when x is equal to 2. So when x is 2, now I look when y is 2, and I get the 2 answers that come here. So remember that if you have g of f of 2 and you're going to work the problem, you're going to work from the inside to the outside, which would mean f of 2 equals something. Take the answer here, so we'll just make up something, say 10, and do g of 10 equals, say 20, and I would say that's my final answer. If, on the other hand, you have g of f of x is equal to 3, you work from the outside to the inside. Okay, so this would be g, so 3 equals your equation. Solve the answer, and then you're going to get that answer is equal to your other equation. So that would just be kind of how you work the problem. And I know you've done that before, so we're not going to spend a lot of time doing that. What we haven't really done before, but is super easy, is going to be when we decompose a function. In other words, I'm going to have a function like f of x is equal to 2 to the x minus 3 plus 4 power, plus 4. And I want to know what functions make up this composite. Okay, so when I'm doing that, I can see I've got a function that's here, it went into here, and it went into there. So I can think of three functions that are going to work here. If I were to say g of x is equal to x minus 3, and I would have h of x is equal to 2 to the x power, and m of x is equal to x plus 4, then that would give me the problems that I had to make up that particular problem. If those were the problems that I used, and there could be other ones that you use with this, I just chose that particular order. The way I would write the composition would be work from, again, from the inside to the outside. The innermost function was x minus 3, so that would be my innermost, g of x. Sorry, my pens and stuff are not working really well right now, so it's kind of being weird. All right, so I would take my innermost function, which would be g of x, and I put that into h of x, which I put into m of x. So I would have this composition would be what I use to make that particular problem. So that's really what you want to do and think about something. And I prefer you not do one that says x equals as one of your functions, unless you just necessarily had to do that. So let's say I have the function f of x is equal to 2 log base 3 of x plus 1 squared minus 7. And I want to figure out what the problems are going to be. So I could look at this and go, well, I have a piece that is here. So I can say, well, I've got an x plus 1. And then I squared that. So I can say my next one could be x squared. And then I put that into the log function, which I put into the function, oops, same name. The function 2x, to which I put into the function x minus 7. So they each have their pieces. Now that doesn't mean I might have had the function 2x minus 7, but I'm gonna try to make sure that you get only one piece of a function in there as you begin. So if I was writing the composition of this, my inside one was g, and then it went into h, which went into m, which went into n, which went into k. So that would be the composite function that I would use with that. So hopefully that was a nice, easy kind of explanation on what you're going to try to do with composite functions, and then working with decomposing functions. And then we'll see kind of why we need to do that as we move on into our next unit, which is composites and inverses.